Okay, so on this question, they have a pretty fancy function for us. Let me just copy it down here. So x, so the first thing I'm going to do as I recopy this, I'm going to make this 1/8 x to the 8th natural log x, right? Because remember, we don't want fractions. Well, and you might say, well, 1/8 is a fraction. Yeah, but I mean, that's just a number multiplied in the front now. So you're right, because I just took that x to the 8th over 8 and I rewrote it as 1/8 x to the 8th, and then the natural log is still there. And then here I'm going to rewrite this x to the 8th over 64 is what? 1/64th x to the 8th. Why am I doing that? It's going to make the derivatives so much easier. So the first thing I do is I rewrite those to make it easier for us to take the derivative. Why is that easier? Because remember, fractions are a big pain because you have to use the quotient, right? You don't want to take the derivative of a fraction. Everybody say, yeah, but it's still a fraction here. And yeah, but this fraction doesn't have an x in it anymore. It's really just a fraction number now, 1/8. Whereas here, it was a fraction that had an x in the top. And this one also was a fraction that had an x in the top. You don't want a fraction that has x top or bottom anywhere because then you're going to have to do the quotient rule. And I try to avoid the quotient rule at all times because it's a pain. So instead, write it this way, make life a lot easier for you. Okay, so let's take the derivative now. And now you know what that 1/8 is going to do. It's just going to sit there because really it's just a number. It doesn't matter if it's a whole number 8 or a fraction 1/8, whatever. It doesn't have an x in it. It's just a spectator. Okay. Now, well, actually, you know what? Let's do this. I forgot. This is the product rule now, isn't it? I better let me get my act together. It's two functions of x multiplied. So product rule, right? Two functions of x multiplied. So take the derivative of the first part. The 8 comes down. Now it's going to go right to the top, though, 8 over 8 like that. X to the 7th. That makes sense. And then the natural log of x is just sitting there. Right? Because its product rule means they take turns. So I took the derivative of the 1/8 x to the 8th, and then the ln x is just sitting there, plus, and then the 1/8 x to the 8th is just sitting there. And now it's the derivative of the ln's turn. What's the derivative of ln of x? 1 over x. A little farther, like that. Minus, and then we're going to do the other one. The 8 will come down. 8/64 times x to the 7th, subtract 1 from the power. There's the derivative. Let me talk you through that again one more time. So the first thing I do is I never want fractions that have an x in them. Instead, I make this 1/8 x to the 8th. That way the fraction is just numbers. Same thing here, make this 1/64 x to the 8th. The fraction is just numbers. Then I can take derivative of this first part, and I notice it's two functions of x multiplied. So I'm going to use the product rule, which means they take turns. The first one goes first, 8 comes there, subtract 1 from the power. The ln just sits there and observes. Plus, now it's the second one's turn. So the first one, 1/8 x, it just sits there, and the derivative of ln x, right there, that was the derivative of that part, and the derivative of that part is just 1 over x. Remember that? The derivative of ln x is derivative is 1 over x. And then the last part, that's pretty easy. That's just, this is one function of x. Let's bring the 8 down, subtract 1 from the power. Okay, let's clean that up just a bit. Not a lot, but a bit. 8 over 8, that just cancels. That's just 1. So we said x to the 7th, ln x plus 1/8. What is this right here? This would be x to the 7th, right? Because this is really x to the 1. 8 minus 1 is 7, right? Because this is x to the 8th over 1. The 8 and 1 subtract. Minus, you can reduce this fraction, divide top and bottom by 8. And it's 1/8 x to the 7th. Oh, and then look at that. Boom, boom. That's nice. And so in the end, it's just x to the 7th ln x. Oh yeah, and that's what they said. Yeah, that cleaned up real nicely, didn't it? And there we go. There's our answer. Now, I know that you might have I'm just showing one version. How about if they also asked a follow-up question? They said, now, because some of your versions might, Now find, and they said f prime of like e to the third or something. How would you do that? It might be a weird thing you're not used to seeing if they stick like e to the third in there. That is a number. It turns out e to the third, right? This doesn't have an x. So there's no x there. It's e is a special number, 2.718, blah, 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 blah. And to the third power, that's a number. They're sticking a number. How do we do it? Well, here's our answer to the derivative. Now they're just going to stick in e to the third, right? So I'm just going to, for example, I know mine didn't ask this, but you might get one like this. Stick in e to the third. So what that's going to be e to the third to the seventh, right? Plug an e to the third in there for x. Natural log of e to the third. So better. So far, so good. So I just stuck the e to the third in for x. So it's raised to the seventh and natural log of e to the third. Now, how do you clean that up? Well, you honestly you could just type the whole thing straight into Desmos, or you could simplify by hand. Let me show you the by hand first, if you want. The seven just comes down there, multiplies. Do you remember that? That's 20. They don't add. Power in one base with two powers, they multiply. I want to make sure that makes sense for you. Why? Because that's what is e to the third? E. And then we have seventh power though. So we have one time, two times, three times, da, da, da. So you got three E's seven times. You got 21 E's, right? That's what that is. And then over here, now, the other trick, do you remember what you can do with this? These cancel, and it's just three. Do you remember ln and e are opposites? They're inverses. They just cancel. It's just three. So there's your answer. You could just type that in. Maybe it might take it. I'm not sure it'll take it. Or you could type it into Desmos. Now let me show you how to type this into Desmos real quick. I'll go ahead and let me just type in the original one, pretending I didn't, just not even simplifying it all. Because that'll work too. Let's just go do that. So if you go to Desmos, here we are. And then I'll go, what was it? So I'll go parentheses right there. Oh no, where's E? Got to go to functions. Oops. And there's E, our friend E. Then you go back to the power page, to the power of the third. All right, and then close those. Oh, whoop, that's not where I want that parentheses. Let me try that again. Go right arrow, and then my parenthesis. So E to the third. Oh, and then that's to the seventh power, to the seventh power. Okay. And then times ln of e to the third. So no, where ln's back over here. ln of e to the main to the third. And you don't need to close the parentheses, by the way. Just hit the button. There we go. There would be our answer. Oh yeah, what is that times 10 to the ninth? Do you remember that means you got to move the decimal nine places to the right. So it'd be 3, 9, 5, 6, 4, 4, 7, 2. Is that move the decimal 1, 2, 3, 4, 5, 6, 7, 7 to the right? So 8, 9, 10. It must be decimal must be right there. That's what that number means. That 10 to the ninth means the decimal should actually be moved nine places to the right. I move it to the right seven places and I get, oh, wait, did I do that wrong? 1, 2, 3, 4, 5, 6, 7. And it should be like that, huh? You move seven places to the right. Um, losing my track. Yeah, seven places to the right. And you're at the edge of the two, and then two more places brings in zeros. So therefore, now the decimal's moved nine places to the right altogether. That'd be the real number right there. It's a big number. It's 3,956,447,200. So that's how you would do that for the ones, I know the ones that say plug in e to the third. You can either just plug it in all straight to Desmos, or you can do a little cleanup. These guys multiply, and ln and e are opposites. They cancel. And you can just type that into Desmos, or maybe it would even let you type that into the answer box. So there we go.